Hello friends, welcome to Joy of Life. So today we are at the 8th episode of System Design Fundamentals. And so before we begin, we are going to take a look at the questions and the comment we have got on the last episode. So Ashish Kumar says, when a server is removed from the ring, how data for that range is copied to its predecessor, the node is gone. So yeah, Ashish, the node is gone, and it is a very common thing in system design that nodes keep coming and going. We decommission several nodes, we spin up new nodes, but again, if you remember, we don't keep the data in a single place. As Ashish mentioned, that this node is gone, then means the data is also gone, and we can't afford to do that, right? So we replicate the data, so we have the data in these places. So what will happen? The rebalancing will be triggered as soon as this node is gone. The data that is being held by this node will be rebalanced in the ring between the other available nodes. So we are going to see in a lot more details in today's episode. Even today's episode, we are going to focus on consistent hashing on the advanced concepts. Mahashakti says, nice bro, nice bro. I think the comment is repeated. So thanks Mahashakti for your comment. I hope you're enjoying the series. We have a comment from Hemal Tandel. He says, very informative video. Thank you. So thanks Hemal for your comment. It means a lot to me. It's a lot of encouragement. I have a doubt about the range. In your example, you come up with a range of 0 to 9999, but it could be anything. So my question is how to decide the ring range. Is it always being static? Means once we decide, we cannot change it in future. What happens at some point we need to increase or decrease the range? So Himal, I think I have already answered your question here. We should always take the maximum possible number, right? There is no sense in taking a smaller number and then try to increase it later. Because if you try to increase it later, all the data that you have, even the server position on the ring goes for a toss. So we should take the highest possible number that is available, and we can go for unsigned int or unsigned long, and we should be targeting for a number as big as possible. There is no sense in having a smaller number. Himal also replied to my comment, thanks for clarification. Is it any drawback of using maximum integer? No, Himal, as such there is no drawback of using maximum integer. It's fine because you are doing a modulus operator, right? So it doesn't matter how big your integer is. Ultimately you are going to do a mod operation and your number is going to come down to the value between 0 to your number minus 1, right? So if you're doing a mod with 8 or mod with 10, you are going to get 10 minus 1 9 or 8 minus 1 7 as the output. So it doesn't matter Himal at all. We have a comment from John Wick as well. So thanks for the video. Overall the series is going on well. Have a small query. So first of all, thanks John, thanks for your proactive participation in the series, and it's always exciting to hear from you. So John says, let's say the total number of values present in the hash ring is as large as some lakhs. Actually John, it will be more than a lakh. So as you have seen over here, it is like, it's huge. I don't know how to say the number, but it's a huge number. It's pretty higher than a lakh. And number of server might be fewer, like 10. Because the server is expensive and cannot have like thousands running. It can have 1,000 runnings like big companies or big products. If you take for example YouTube, they will definitely have more than 1,000 servers running, right? So it can have, but not in all cases. So yeah, you are right, it will be 10 or even lesser than 10 at times. So as per consistent hashing, if we just have 10 servers sitting in such a big ring, although the load is getting distributed equally, still the load would be on the higher side per server, correct? Absolutely, John. You brought up the right point. In the last video, I didn't wanted to cover because I wanted to stick to the basics of consistent hashing. I didn't wanted to introduce vnodes or the virtual nodes and put a lot of pressure on the viewers who are starting fresh or starting new. So to mitigate this, there is a concept of vnodes, right? And this episode is all about vnodes. Could you please brief us about that? Definitely, this episode is dedicated to you, John, and we are going to discuss about vnodes. And as you mentioned on your comment over here, the load is getting distributed equally. This is true to some extent, but might not be true all the time. It might vary. Sometimes it might become a hotspot wherein a particular node or a server is taking up a lot of heat, we are going to see all those examples and try to understand them in lot more details. So with that, let's start with the vnodes. Let's understand the problem. Let's understand or revisit what we have done so far, and let's see how vnode can rescue us over here. So before we begin, I just wanted to reiterate what Ashish has mentioned. It is quite common in distributed system where we decommission node or a node may die, it lose connectivity. There can be so many things that can happen, right? Similarly, adding new nodes is also very common, right? To meet the growing demands. So let's say I have a ring over here, and let's say this is my 0. Let's take a smaller range today. So let's say 0 to 100 range I'll take. So here I have 25, 50, and I have, let's say, 75 over here. So let's say I have two machines and two of the machines are sitting on the ring somewhere over here at, say, position 20, and let's say at position 70. Let's say, just for the sake of simplicity. So two nodes are sitting over here. This is my node N1 and this is my node N2, right? So both of them are taking the load and everything seems to work fine. Let's say these two machines have a similar configuration and they can take up let's say it can store about 100k records, just for the sake of simplicity. So let's say we have 100k capacity, so our total capacity is 200k. I see my application growing and it has reached around 160k, and I know soon enough I have to add more nodes, right? So let me introduce a new node over here. So at position 35 I introduce my node 3, and which is going to take the subset of the request. So in this case, what will happen is node 1 is going to share some of its load with node 3, right? So previously, node 1 was serving the request from 20 to, let's say, 69, and node 2 was serving request from 70 to 19, right? And now node 3 has come into life and the ring has assigned him 35. So 35 onto 69 will be served by node 3. So this will change. So he will serve till 34. All the values that are greater than 35, it will be transferred from node 1 to node 3. So this act is called rebalancing. Now let's take the similar example once again and let's try to understand what can go wrong over here. So let's say again we have the same range as we had, so 0, 25, 75 and 50, and two of my machines are sitting in the same ring at the same location. So at 70 I have one node sitting here, and at 20 I have one node sitting over here. So you can see over here that both the nodes over here is assigned a big range, right? So in a normal consistent hashing, what happens is N1 and N2, they are given two ranges. So 20 to 69 and 70 to 19, right? All the way through 0. So now as we add a new node over here, so this node is added at 85. So you can understand that node 2 and node 3 is now participating in the rebalancing. So node 2 has been overloaded with the rebalancing act, right? He has to move a lot of data. So let's say if we have a bandwidth of 200k and he's holding 100k and he's holding 100k records, that means almost 50k records need to be rebalanced only at this node, which can become a problematic thing. There can be other kind of problems as well. It might also happen that my node, this node is having only 30k of record and this node is having 90k of record. So you can see that there is a severe unbalance between these. So the number of records falling between this node and this part of the ring is much higher. We have lot of records over here, and comparatively we have lesser number of records over here. So you can see that this has become a bottleneck. This kind of problem, it's called a hotspot. So this node has become a hotspot. So if we are going with a big range that we have seen over here, 20 to 69, 70 to 19, now just increase this number from 100 to let's say 100 million. He's handling a huge range. He's also handling a huge range, which is not good. So to address problem like this, we have virtual nodes to our rescue. So let's understand how virtual node works in order to counter this kind of problem. So we saw that adding and removing of node is causing a problem, right? It is causing a massive problem. If I want to remove this node also, you can understand I have to give all his data to him, which is also not good. So this is again going to make them busy, right? So adding or removing of node is a problem. One node becoming a hotspot is a big problem. And then we have the node rebuilding. So since each node's data might be replicated, right, to a fixed number of other nodes that we know, that we have seen, that we replicate it to the other nodes. That is the deduplication part. When we need to rebuild a node, only its replica node can provide the data. This puts a lot of pressure on the replica node as well. And in this diagram, if this node goes off, right, these two nodes has to provide 500k objects to the new node. It's a big load on these two nodes. We don't want these things to happen. To handle this kind of issues, consistent hashing introduces a new scheme of distributing this token. So here we have seen the distribution is single and the range is large. So we have seen this large range and single token to each one of the physical nodes, right? But we are going to change this approach. We are not going to stick to this approach because this approach has some limitations. So instead of giving them big ranges, we are going to hand them over smaller ranges. So let's understand how. So once again, let's say this is my range of 100. So 10, 20, 30, 40. And this is my 100 or 0, right? So we have this range, right? So previously, let's say we have two nodes, right? So previously what we have done is we have just put two nodes. Let's say we have added one node at 20. So we had a node over here, N1, and at 70 at node 2 over here. So what has happened? 20 to 70 is N1's range. That we saw previously, 20 to 69 rather. And for N2 we have seen that it's 17 to 19. So that was the problem. Now how we are going to solve this problem is we are not going to give him one range. So what we are going to do is, let's make N1 and N2 with two different colors. So let's put white. Okay, so what will happen is, let's say 0 to 9, this range is for N1, right? And similarly 10 to 19 is for N2. Again, we will put 20 to 29 for N1, and we are going to repeat this process. We are going to put 30 to 39 for N2. So what is happening is this range is N2's range. This range is N2's range. This range is N2's range. Similarly, this is N2's range. These are all N2's range. And the one in between are N1's range. So you can understand that how we are giving smaller range, right, to each one of them. So let's understand how this helps with a broader example. So let's say again we have a range from 0 to 100, and let's say this is my 0, then we have 10, we have 20, we have 30, we have 40. So let's say this is my ring. We have 0 to 100 and we have two machines, right? And what we have done is we have assigned virtual nodes to each one of them. So we have a range from 0 to 100 and now we have four machines. So what we are going to do is we are going to put these machines with different ranges. So for 0 to 10, we are going to put N1 over here, N2 over here, N3 over here, N4 over here. And then we are going to repeat this entire process. So N3, N4, again N1, N2. So even if a particular node becomes hotspot. So let's say the hash value that is produced is higher between 75 to say 90. So 30% of the values are produced in between this range. So in a system like this, it will overload this machine over here. But over here, what will happen? We are seeing a higher load between 75 to 90. So that means we are talking about 2 or 3 machines, not a single machine, because we have given them smaller range, and that's how we have averted the problem. Let's say the load was higher between 25 to 90, just for the sake of understanding. So in this case, 25 is over here and 90 is somewhere over here, let's say, right? So again, this machine is going to get lesser load, but this machine is going to get blasted, right? This was going to get a lot of traffic. But over here, 25 is somewhere over here, 90 is somewhere over here. So you can see that almost all my machines are getting equal number of nodes. So not only this, there are several other advantages that you can get out of your virtual nodes. So on a normal, we have seen single token, large range. Here we saw that we have multiple token and small range. That's a very simple way to solve this problem, right? And it has other benefits as well. So we talked that the rebalancing was a big problem, right? Now the rebalancing will happen at a completely different way. Again, let's take a ring over here, and the range is 0 to 100. So we have 25 over here, 50 over here, and 75 over here. So very simple, right? We have 5 nodes. Let's say we have 5 nodes, right? So it's simple, 25 by 5. Let's take a very flat example. So each of this 5 is going to one of the nodes. So this is N1, N2, N3, how many? N5. So this is 1, 2, 3, 4, 5. 5 nodes, and each one of them is getting one chunk, right? Now let's say I wanted to introduce a new node, right? So I wanted to get the 6th node over here. So what will happen is they need to readjust. So it's like a bench, you can say. So 5 people are sitting on the bench, and now you want to introduce the 6th one, right? So they have to accommodate, right? So they were each holding 5 units in the range, right? So they have to compromise. They all has to do a -1 and go to 4, right? And this all node will contribute on the creation of the 6th node. So now what will happen is, till it was 25. So here we will have 4, 4, 4, 4, 4, and 5. So this is how the 25 will be. So you can see here, now as I introduced a node, all the nodes has participated. N1, N2, N3, N4, N5 all has participated and contributed to N6 in order to build N6. So what has eventually happened is they lost only 1 unit from their token range, right? So it was still 0 to 6, it was still 0 to 5, and it became 0 to 4. So each of the node has lost quite a less compared to the bigger approach or the bigger range that we have seen over here. We saw that here the load was on only 1 and he only lost everything, right? Previously we have seen that when you have 5 nodes and if you wanted to introduce a new node, right? So if the node goes to this position over here, only he is the one participating in the rebalancing. But now we see that everybody is participating in the rebalancing. So what will happen is the load will reduce. Each of the node will have a role to play in the rebalancing, and it will have a lot better performance when it comes to the rebalancing. And also keep in mind, if you see this diagram, that we should not give contiguous spaces, right? So it should never happen that this is N1 and this is also N1. So then it becomes 0 to 20. So there is no point. So it should never be contiguous. It should be randomly. So you can see over here that N1 is here, again N1 is over here, again N1 is over here. So they are almost equidistant from each other. So that will help you in both the rebalancing work as well as in the mitigating the hotspot. So we have seen over here that vnode helps spread the load more evenly across the physical nodes, right? So there is no chance of getting hotspot at this moment. And how do we do it? By giving them smaller subranges. So rather than giving a big one, we are giving smaller subranges. So this speeds up the rebalancing process. After adding or removing the node, it will be very fast to get the data or to share the data. And we have seen that as a new node is added, everybody participates in order to build that node, right? So this is a very natural and a practical thing, right? If you want to build a building with 5 people, it will be faster compared to building it with a single person, right? So in this approach, we have seen building a house with a single person, and here we have seen 5 of them contributing, or all of them contributing in building the house, right? So it will be much faster, definitely. And vnode makes it easier to maintain the clustering as well, for especially when you have your heterogeneous machines. So over here we have seen that we are giving the equal number of ranges to everybody, right? So now let's see, I have two machines, N1 and N2, wherein I have 64 GB of RAM and 1 TB of hard disk, right? And let's say I have another 3 machines, so N3, N4 and N5, who has a 32 GB RAM and 500 GB of hard disk, right? So I can tell that give them only 2 subranges, whereas give them 5 subranges. You can control the subrange division among them very easily, right? So if my systems differ in the configuration, I can easily configure them to have different number of subranges. So the powerful machine gets more number of subranges, and the smaller machine or the less powerful ones get lesser number of subranges. So he will have 5 subranges. So same for this guy as well. He has to deal with 5 subranges, whereas these guys over here has 2 subranges only. And we will mix and match and put them in the ring like this over here, as we have seen. So in contrast to one big range, since vnode assigns multiple smaller ranges to each of the physical node, this actually eliminates the chance of creating any hotspot into the system. So this is the concept of the vnodes. I wanted to share one image which is very similar to the same image that I have drawn over here, but since my drawing skill is pathetic, so I thought it would make sense to show it like this. So this one over here is without the vnodes. As you see, we have 4 servers over here with huge ranges. So each of the range, you can see it's pretty big. Now the same 4 servers, we have vnodes. So you can see that first server is present here on a small bit, here, here, here. Similarly, second server and third and fourth and so on, right? So it really helps a lot to a great extent when you use the vnodes. So with that, I will end this episode over here. Do let me know if you have any questions, comments, doubts. And in the next episode, we are going to start with the caching. And we'll also try to go a little hands-on. I think it's time. We have covered a lot of theories. I know John has already told me to cover a lot of them. 2PC, 3PC, saga, there are many things John has already given tasks to me, and I am definitely going to cover them. But along with that, we'll also go a little hands-on so that we can understand what we are doing and how it is going to help. But again, I would request you all to share your doubts and questions in the comment section. And in case if you don't have a doubt, please leave a comment. It motivates me a lot. And definitely it feels great to hear from you guys. So do let me know in the comment section. I'll be waiting and I'll be reading them on the channel on the next video. So please share your thoughts on the video. And do let me know how I can do it better and how I can help you guys more. And I have shared one feedback post over here, so it's anonymous. Please go out and give your feedback. What do you think about the series? So most of the feedback is wow. So I am really happy to hear that most of the people is feeling it's nice or wow. And somebody has given a rating of scope for there is a scope for improvement, and I completely agree with you, because when I see the video after a week, I also feel the same, that there is a huge scope for improvement. So it's always good to hear from you guys. Please go ahead, give a comment. So lately I was a little laid back, was enjoying my time playing some PUBG and doing some unboxing, exploring my new GoPro as well. But yeah, time has come again to get back technical. So do let me know. I'll wait to hear back from you guys. So that's all from this video. So see you soon again. Bye bye and take care.